This is for experiment 3, the Ohm's law. In this experiment, we need these supplies. We need 3 different resistors. We need one 330 ohm resistor, a 100 ohm resistor, and one 220 ohm resistor. And we need breadboard, the 9-volt battery, the multimeter. We need to connect the circuit using some wires. I have already put some wires to the breadboard. So here, this one, the black wire, later connect to one side of the resistor. The other side connect to the blue line, which attached to this wire. This wire connect to the negative terminal of the source, which is the battery. The red wire connect to the positive terminal of the 9-volt battery. That bring the voltage to this red wire, and here links to the other side of the resistor. So let's see. If you look at the first table, table 1, we need to measure following numbers. R1's value, the measured value. R2, R3, their measured values. We also need to measure the source, which is the 9-volt battery. It's supposed to be 9 volt, but when we measure it, it's a little bit different. It should be a little bit different. So now let's begin. We should begin from step number 1. So first, let's turn on this meter. We need to measure the resistance first. So here, change that to ohm meter mode. And then we can pick the first resistor that we need to measure, which is R1. R1 in the table is 100 ohm, this one. So take that one, put the hook here, and the other hook to the other side of the resistor. The reading is 102 ohm. So here, this should be 102 ohm. So write it down. There we go. And now disconnect that resistor and take the second one. That is the 220 ohm resistor. Follow the same step to measure the resistance. It's 216 ohm. Supposed to be 220 ohm, but the actual value, the measured value, is 216 ohm. There, 216.0 ohm. Next, disconnect that resistor and pick the last one. There we go. So here, this one, that one, is 330 ohm resistor. Supposed to be that one. That's the theoretical value. The actual value is close. It's 328.0 ohm. So 328.0 ohm. It is here. So we finish measuring the resistance experimental value, also called the measured value. Put it back, make sure it's clean and organized. Next, we need to measure the voltage source value. It's supposed to be 9 volt, but it is not. So we can connect that here to the alligator clip. And this connect to, no, don't do that yet. Make sure we need to switch here to the DC voltage mode. So I haven't connected that yet. Switch here to the DC voltage mode and now connect. Make sure the red cable, the red probe connect to the red lead. The black cable or the black probe connect to the negative side of the power source. It is 8.84 volt. So I will put that here. It's not 9 volt, it's 8.84 volt. That's the actual voltage of this source. the 9-volt battery. Okay, now we can move to the next step. So this connect that, this connect here. Now we need to connect the source, the battery to the circuit there. And put that here. Okay, this is still a open circuit because there's no connection between these two wires. We want to put those resistors here one at a time. Begin with R1, that is the 100 ohm resistor. So I will pick a tweezer and then put that there. Here. Next, we're gonna measure its voltage. This is in the DC voltage mode. And then connect the probes or the hooks here. This red hook connect to the side closer to the source, which is the red one. And put that to the other side of the resistor. We are measuring the voltage across that resistor. That voltage is 8.12 volt. So over here, the measured voltage for a 100 ohm resistor, it is 8.11 volt. So write it down. There we go. Next, we need to measure the current. The current that goes through here. This becomes a little bit harder, not that hard, but hard because it's new. To measure current, we need to place the meter, the probes were in series with the thing that we need to measure. That thing in this case is the resistor. So I will do following first. So unplug one side of the resistor, either this side or the other side, or we can simply unplug a wire. Just form an open circuit. I would pick that wire. This wire is longer and easier to unplug. Next, I may use a jumper. Put this jumper here. You don't need to have this jumper. With a jumper, just make the connection easier. There. And later, I'm gonna use these hooks, connect both wires. Before that, we need to do two things. First, I need to switch here to current mode. This is the DC current. A stands for amps, ampere. The amp meter mode. So this is step one. Make sure select that for DC current. Unplug here because that port cannot measure current, only that one. So put this here. Now the configuration is ready. This meter is ready to measure current. When we measure current of the circuit or branch, make sure the meters is in the series to the thing that we are measuring. So we're gonna connect that here. Connect the red one, the red wire or the clip, this to the circuit that bring the current into it. So current will come from the source, the battery go through here and enter this red lead. After entering, you just flow through this meter and it come out from this the black port or cable. So put that there. Current will exit from here and then go to the ground. That forms a closed circuit. The reading is 0.082 DC amps, or which is 82 milliamps. So I will write it down. I will put either this number 0.082 DC amps or simply 82 milliamps. I personally prefer the number with prefix, so I will put 82 milliamps. That. And here we need to calculate later. Next, move to the next resistor, a 220 ohm resistor. So make sure disconnect those. And then I don't need this jumper for measuring voltage. Unplug that resistor, put it back. This might be a little bit hot, so be careful. And pick the second resistor, the R2, which is 220 ohm. Connect that back here. And then bring this wire back there to form a closed circuit. There we go. Beautiful and neat. We want to measure the voltage of that resistor now. So the probes, make sure unplug that cord, the plug, put it back here for measuring voltage. Switch this knob to DC voltage mode. And then now we are ready to measure the voltage. Again, the red one connect to the place, the point has higher voltage, which is this side. So the other one connect to the resistor with the leg attached to the lower voltage, which is the ground side there. The voltage across the resistor is 8.35 volt. So write it down. 8.35 volt. There we go. Now we need to measure the current go through the resistor. Just like before, disconnect that. This time I want to disconnect this leg. Just do something a little bit different from before. Unplug that port or plug, put that back here for measuring amps. Change here to DC amps mode. Now we are ready to measure the current. Connect that. Let me put that firmly. Connect that to here. And the other plug there to need a jumper. Okay, so connect that to here. There we go. The current drops to 0.040 amps, which is 40 milliamps. So write it down, 40 milliamps, that one. And then next, right after we get all the numbers, we need to calculate this by hand. Okay, now let's move to the third, which is the last resistor, the 300 ohm resistor. So I'm going to remove that resistor first, put that here, and take the 330 ohm resistor. Remove or unplug this jumper. Put that here. Okay. So now it forms a closed loop for the third resistor, the 330 ohm resistor. Now we're gonna measure its voltage. The same probes, but before that, unplug this cord and then put it back there for measuring voltage. Change that to a DC voltage mode. And now let's do it. So the red one connect to the side of the resistor attached to higher voltage, which is close to the positive terminal, right, that side. So this connect to the side closer to the ground. The voltage across the resistor is 8.46 volts. So write it down. 8.46 volt there. Next, we need to measure the current. So just completely same procedure. This time, I'm going to try one more thing or differently. Unplug that wire this time, just to show the result is same. We have more than one way to do it to measure the current. We have more than one location to insert the meter. So this is unplugged. Later, I'm gonna put this clip over there and then put a jumper here just to make our life easier for connecting the probe here. There. Okay. Unplug that one, put it there for measuring current. Put that here. And then put this there. Before that, very important, make sure this change to DC amps. Otherwise, we can even burn this meter. There's a fuse. That fuse can be burned. So now everything is good. Connect that to here. The reading for the current is 0.026 DC amps, which is 26 milliamps. So write this down, 26 milliamps. That. And then next, we need to calculate the resistance. This resistance is the calculated resistance based on the measurements, based on the measured voltage and the measured current. So we can calculate that. This one, that one. This number should be very close to those numbers. Should be very close. And after that, once we have this number and we have the current plugging there. So let me give example. So after using calculator and calculate the numbers, I get 98.9 ohm. This is the calculated number, but based on the measurements. Expected number should be 100 ohm. I calculate that to be 98.9. This one is 208.8, approximately equal to that, which is close to 220 ohm. This is 325.4, close to 330 ohm. Those are the expected number. These are our measurement. So if you compare this to 100.2 close, 208.8, here is 216.0. This is 325.4, this is 328.0. So they are pretty close. For here, we need to plot these points. Before that, let me disconnect here and get some space. Okay, so this is the meaning. We're gonna plot the points for R1, R2, and R3. For R1, if you look at the plot, the x-coordinate is the resistance. For the first one is 98.9 ohm. 98.9 ohm right from here to there, that's 100, half is 50, so 98 should be very close to that, very close to 100 ohm. The vertical axis is the current, 82 milliamps, 82 milliamps. So this is 80, 82, just a little bit higher than that, perhaps there. This should be the first point. There. For the second one, R2, the resistance we got is 208.8. This is 200, 208 should be maybe around there. And the current is 40 milliamps. This is 40 milliamps level. So that intercept should be there. And for R3, we got 325.4. 300 is that. Between 300 and 400, half of it is 350. Half of that is 325. Maybe that, there. So this is about 325.4. And then the current is 26, right? This is 20, 30, half is 25. A little bit higher than the middle point between 20 and 30 milliamps. So that is 26 milliamps here. This is the point. And it's good to have more points. However, in this experiment, we only use 3 resistors. Due to the reason why we have a limitation is the voltage source. It's barely 9 volt. And we can connect these 3 points using a curve. It looks like this is the trend. It's not a linear, but this is the trend. So based on that, we can conclude if we reduce the resistance value to that side, this side, and then we can get a higher current. Otherwise, if we increase the resistance right to that side, based on this trend, we can predict the current will be smaller and smaller, maybe eventually become 0 when the resistance is too large. So this is just a graphical way to see what's going on here. More resistance, small current. Smaller resistance, higher current. So this is experiment 3.